Hello and welcome to the channel. In this video, we'll talk about what Jetpack Compose is, how it is different from the traditional way of building UI, and why it matters. So, in traditional Android UI development process, we had an XML file which has like a backing Kotlin, which should be a fragment view file or an activity, which hosts the layout. So what happens is that you had this canvas in your Android app in which you used to lay out your views. It could be a text field or text view. Then it could be another view which is like a black in color. So you had an XML file to do it. Then you had a hierarchy of views in which you had a container. This container was like a layout, which is more or less a relative layout or a linear layout, or you must have like a constant layout if you guys got this particular layout. So these layouts like container layouts or view group as they are called, which can hold multiple views. Now this relative layout, this is a relative layout, which will have the children's laid out in a fashion where this view is starting from the parent, and now you will have another view which will be like below with the ID of this particular view. Then you will have a circle, maybe like a view which is like a custom view, and it's called circle view. And you will have like a below this and at the end of the parent or at the end of the view. So that's how relative layout was. But every view was relative to other view or maybe the containing view. Now, if you wanted to change, let's say let me talk about this particular text view. So if you wanted to change this text using Java file or like an active in or activity or a fragment. So you would have used find view by ID, in which you will specify what sort of a view it is, and then you will r dot id dot some ID here. Just quickly move this up. R dot id dot some ID. So this is like in that particular layout hierarchy in which you had your view. This is the on the layout hierarchy. This is like your window. In this window, you have this relative layout. In this relative layout, you will have quite a few views, and one of the view is this particular text view. So you are traversing that particular layout hierarchy and getting hang of or getting an instance of this particular view, which is being ID'd via this particular field, and you'll find this view by this ID. And once you get this ID, you get this particular text view as an instance, as let's say TV, just a random text view. Now, whenever you wanted to change the content of this text view, you will call set text with a new value, and this value will in turn get rendered onto your text view. And whenever you want to change this particular text on that particular text view, you will always have to call this set text. And now your UI will accommodate the change. So what changes with Jetpack Compose? So as of today, if we talk about this particular UI mechanism, we are more or less talking about how you want to draw the UI. It doesn't talk about what, because you are in control of that in your activity, and you can just call the setup functions and you will be done with it. But now, when it comes to declarative UI, how it changes the whole game is that uh, now you don't have setters, you don't have anything. You just lay out your UI. So I will have like the same card in here. I'll have the same text view here, and it will be rendering some sort of a data. The data is uh, header title. It's a variable. Let's say it's a variable, but it's a state variable. So what do I mean by state variable? So whenever this particular variable changes, whenever there is a change in this particular variable, your composable, your this particular widget will go into recomposition and will automatically render the change. So now your view is not how you want to draw it. It's more or less backed by a data set or a data holding variable or a data variable or a state variable. Whenever that variable changes, your composable will render itself to accommodate that change. That's how the whole UI shift is like the paradigm shift is different from the imperative to declarative. In imperative, you are worried about how you want to draw it. So you will just go into layout file, you will draw it, and you will be done with it. In declarative UI pattern, it's not about how you want to draw it. It's about what you want to draw it based upon what state. So, like I'll just move away from this particular screen for now, and I'll just go into my activity file. So let's draw something and let's see it in real time. And let me just pull up my emulator as well. So now it's if you create a new project and you choose empty compose activity, this is the first thing that we get to see on this particular file, and I have changed nothing into it. Just think that okay, I'll just remove these non-required things, and I'll just have. Let's say that I have a text field. I have a text, and this text is let's say I am clicked dollar number times. Now I'll create a variable number times equals to 0. Okay. Now this is surface, so we cannot just use it to draw layout or draw views in fashion of linear layout. So I want a button below this text view. So I'll use a column. Column is something similar to what linear layout is. I'll copy it, I'll paste it here, and I'll also have a button. Now button is something that will do our job, and we'll call number times equals to number of times plus 1, or b plus equals to 1. And this also have a child. which will be a text, and I'll just have it a name called click me. Now you'll see that I have a variable based upon which we have a number times, which is a variable which holds a default value of 0. And when we click on it, we increase the number by 1. And we should see the text that now let me just rerun it. Whenever we click on upon it, you see that nothing happens. So why did I create a variable that doesn't work? So in order to understand this, this is a simple variable. This change in this particular variable will never go into a cycle where your composable will re-trigger its own recomposition. It should be part of state. So what do I mean by that? What is that? So let's say that I have number times. Now I want to have remember. So we'll talk about remember and other remember savable and all that stuff into a video where we'll talk about the content compilers. Zero. Now number times dot. Let's consider that now it will become a state sort of a variable. By this, remember, you just mean that the composed tree and the nodes using this particular variable will have it saved in with their internal representation. Now, when you click number of times, whenever you click a button, number of times will change. That change will trigger this composition and the text will recompose. Now, let's run it and see if it works or not. Now, if I do click, it still doesn't work. And ideally, technically, it should work. Why it's not working? Now, there is a reason for that. Now, you remembered that it should have a zero value, but it's a state, and we pass in a state of zero. Now, number times dot value will have the integer value, and whenever we want to change that state value, we will have to do this plus equals to 1. Now, we can move it to val, and if you want to use it as a variable, you can use by, and we'll have to import get value and set values of this. You can do this as well. Now it's a variable and you can directly change its content. But I always prefer my keeping my variables as immutable. So we'll go and see like now if I click on it, it works as expected. Now let's again move it to val and do that value thing so that we don't have a variable which can be mutated. Rather than now if I rerun it, so it works. Now if you see like how it's different from the traditional way of building UI is that in traditional way you would have like a button which will be having find view by ID, and you will have r dot id dot button ID. You will specify the type that what sort of view it is, and it will be a button. You will have like a var which is like a stick count which will be 0. Now button dot set on listener, and then you would have called that click count plus equals to 1. And then you would have set another, let me duplicate it, text field, text view, text field, r.id.tv, and then you would do t.setText, click dollar, click count times. So this is what you would have done in the Android traditional Android system, where you would first of all get hooked to what sort of view you are trying to render. Then you will go to that button and then you raise set of click listener, and then on that click listener you will increment a variable. That variable then after incrementing that variable you will set the text again. Now you see that how it is different and why Jetpack Compose has a very natural sound to it, because it's backed by the data which whenever get changed will re-render the UI. So this will be all for this video, and for the upcoming video we'll talk more about like how to start building apps using Jetpack Compose, and how to think in Compose basically. It will be not a standard, what do I call it, a video where I'll have something planned out. It will be basically a way via which I think on my own. That's how I think while building an app, and will move forward towards building a full-fledged app. So I'm planning out what sort of an app should I be building, and once I get to decide that, and once I have a final decision on it, that what sort of an app we are going to build. Once I am like clear about that, I will start building that app from scratch, and we'll see like how composables or like screens when we deal with backend APIs or do some logical processing into it, or n number of things that we in the app world use, and how does that uh, matter, and how to think in a way that's not aligning with the existing view based system where you had an XML file, you will just think about the UI and how the UI looks in, and then you can try to accommodate into your activity or fragment file based upon your data. Rather than I'll I'll make sure that in those videos I propose a mental model in which you think about data, and based upon data you draw what you want to draw. More or less, it's not how you want to draw, but what you want to draw. That will be all for this video. See you in the next video.